Hello guys, welcome to the new video again. In this video, we will discuss uh, lecture number 50. This is the lecture number 50. In this, we will discuss finite automata with output and what are the examples of that with output, Moore machine and Mealy machine. Okay. So if we talk about finite automata with output, so examples are Moore machine and Mealy machine only. So we will discuss. We can also say that finite automata without output would also known as acceptor, and without output known as transducer. So, so in this there is no output, so it can accept the language or reject the language. Right? The input we can say. So finite automata with output without output is NFA and DFA. We already discussed that, and applications tokens. Application of that is tokens recognized, a token recognizer, spelling checker. So these are some applications of finite acceptor, and some transducers. Example are Moore machine and Mealy machine. Applications of that transducer is sequence detector, alright, generator, sequence generator also, increment, decrement, addition, subtraction, etc. We can do with this, alright. Moole machine and Mealy machine. So we will see how this sequence, how they can detect the sequences, and if output 0 is output 1, so yes or no, we can say outputs will be generated. So how this works, finite automata, how finite automata works is that there is a input table, right? There is a string. First read this string, all right? So what is this going on that it read A, all right? Then go for this, then for this, for this. If it at the end of the string, if the state of the FA is final, then accept, else reject. But in the case of uh, what we can say machine with output, so in this read write header is this, input tape is this. So this tape is input always as well as output. All right. So what is this going on that if some string is given, all right, we match this string with this, we are going to detect that. So this is selected, so the output is 1, all right. This is output is 1, this is matched, output is 1. If this does not match, all right, the output is 0. If we get output 0, all right, so it will this is how we give outputs and inputs, all right. So input alphabet is going to be 0 and 1, and output alphabet also 0 and 1. It can change also, right? Not necessarily be the same, that output alphabet is not always equivalent to input alphabet, all right. Does not belong to, or we can say, so output function is this, right, and output alphabet is this. This is the tuple of finite automata with output, and this is a set of states and set of input alphabet. This input transition, state transition, we can say initial state, and this is output alphabet, and this is output function. So we will discuss Moore and Mealy machine. So what is Mealy machine is that this is transition. What is this? This is the transition function of input, and all right, and this is Q. All right, it will generate some transition function of what we can say transition of uh, transition of any input. All right, transition is this at is any state Q. All right, will give an output. What we can say that uh, will go to the output alphabet. All right, some give some output. So note the transition is this. Yes, output is associated, all right, If any transaction take us to any state, then according to that state, there is associated an output. All right. So output is associated with state. All right. In Moore machine. All right. In Moore machine, you can say in Moore machine, output is associated with the state. All right. If what we are saying that this state is q naught and output of this state is x, and q1 is out state for state q1, output is y. All right. So if we are at state 1 and if we get the input 0, so we will uh, remain at state 1, but the output we will give is x. All right. At 1 output 1 y, and this is so on and so forth. In the melee machine itself, we at the what we are doing that there is a state, we will take some input, then it will give some output, right? So what we are saying, this is melee machine. All right. Melee machine, output is associated with transition. Right. Output is associated with transition itself. All right. Where the transition is going, right? So if we are at q node and we take the input a, then output would be, if we are at state q now and we take the input, what take input, what we are saying that a input. All right. So output would be a, zero input, output would be then a. All right. This is how. So transition of q naught comma 0 will result in output a, and transition of what we are saying q naught comma 1 will result in output b. All right. So this is how 1 and B, and for 1 and A, 0 and D. This is how transition works. This is melee machine. Yeah. So in melee machine, what we are doing that there are I1, I2, I n transitions, all right, and transitions, all right. So what we are saying that number of state is q is equal to 2 and number of input alphabet is 5. All right. Let's see, for example. So max site of input alphabet would be, what was the max, it will be 5. All right. Always. All right. So max, what we are saying, max site of output, so it would be transition, magnitude of transition, that is magnitude of transition from transition, so it would 10 number of transition if every transition have different output. All right. Yeah, if every transaction has different output, then 10 outputs, else the 10 transitions only. In Moore machine, state as q is equal to 2 and this is 5. So what we are saying, number of different outputs. Number of different outputs is equal to 2 always. Max 2 is q only. Number of q, 2 number of state. If every state has a different output. Only if every state has, what we are saying, different output. Right. So what we are saying that in Moore machine, we are saying that a comma x to 0 and say 1. Why I'm even making this, right? So in Moore machine, what we are saying that a comma x going to 0. All right. So this is Moore machine, output is x, for state b output is y, transaction is this, transitions are there. So what we are saying, for epsilon output would be what, x. All right. X is the output. For 0, a 0 will be, output is always x, and input epsilon, output x. Input 0, what we are saying that output x, what is this x? So x for the this and x, and for 1 x and y. But for 0 0, what we are saying, x is the epsilon 1, and for null string then x, for 0 1 x x y, and 1 0 we've been saying x y x. Is it? Yeah, this is how it goes. This is by default output associated with initial state will be produced by default output. So this is by default output. All right. So by default output. Right. This is an important note to do. And in Moore machine, or what we are saying in Moore machine, by default every state associated with one output symbol. By default every state in Moore machine, by default every state associated with one output symbol. All right. If n length input is given, then so output length for given input. So if n length input is given, then output length n plus 1, because 1 is default. 1 is default, all right? N length. So yeah, if n length input is given and every state is associated with 3 length output, then 3n plus 1, all right? This is the output length for the given. In Mealy machine, if the input is 0 0 0 1, so for first there is no what we are saying output, so epsilon is nothing. For 0 it would be x only, for 1 it would be y, for 0 1 x and y, for 0 1 is it complete, for what we are saying 0 1 0 0 double x, and 0 1 0 would be y and x, I think, and 1 1 it would be y. This is how it works. So for the input, that this is the input. Initially we are at this state, for we are getting 0, output produce 1, always. Right, a only, we get 1 here, we get b here, output is y only. This is the output in Mealy machine, right? So only n and 3, right? This is how it works. Mealy machine, Moore machine. Moore machine and Mealy machine. AABA. Care CH. What is this? VE. First it will read it and shift to y right, and read it and shift to y right, and this. Finite automaton and length input space is order of 1, time is order of n. So in Moore machine, it will read and generate output, read space is order of 1, only the storage, and time is order of n. Yeah. A Mealy machine, both are DFAs and finite states are not there. Both are DFA and final. There is no final state. Final state does not exist without DFAs. Alright. So language accepted by finite automaton, whether given input is valid or invalid. Input where it is holds or final. Functionality of finite automaton. What if is the output of, so for input and output. This is a functionality, and Moore machine and algorithm to interchangeable by both of them. And homework, construct Moore and Mealy machine once complement one the, oh, right. So we will discuss more detail about Moore and Mealy machine next lecture. Thank you so much, and we will meet in the next one. Right.